Hi and welcome to video 2 for section 12.6. This is the second of 3 videos. As I mentioned at the end of the first video, Pascal's triangle is useful, but not for once our value of n starts getting large. It would take us forever to try to get to like the 85th power to see how the coefficients work out. But fortunately, we have the idea of the binomial coefficient. And so for the binomial coefficient, we have the following. Let n and r be non-negative with r is less than or equal to n. The binomial coefficient is defined by so we have this notation, n, r, inside of parentheses, but notice it's not a fraction. I don't have a bar over the top of these, it's just n and r in the parentheses, and this is referred to as n choose r. If you have to take a statistics class or probability class, you'll use this a lot, this idea of n choose r. And what this notation means, if we break it out, it means n factorial. Well, n with an exclamation point, which is known as n factorial, over r factorial times n minus r factorial. So I'm like, okay, great, you told me that, but I still don't know what to do because I don't even know what n factorial means. Well, now you will. Because, by definition, n factorial means n times n minus 1 times n minus 2 times n minus 3 times dot 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 all the way till you get times 4 times 3 times 2 times 1. So for example, if I have 5 factorial, this means 5 times 4 times 3 times 2 times 1, which is what? 5 times 4, 20. Times 3, 60, times 2, 120, times 1, 120. So note, so that's what n factorial means. And r factorial means the same. R times r minus 1, times r minus 2, etc., etc. But just note, if we have 0 factorial, so notice r is less than or equal to n. So if r is 4 and n is 4, well, that means what? We'd have 4 factorial over 4 factorial over 4 minus 4 is 0. 0 factorial. 0 factorial is just equal to 1. So, let's look at a couple examples. What if I have, for the first one, 9 choose 4? So this would be what? By definition, so our n is 9, our r is 4. So this would be 9 factorial over 4 factorial times n minus r. 9 minus 4 is 5. And please do not forget this part. So 9 minus 4 is 5, so 5 factorial. What I see all too often, and this is what will cause you to get the answer wrong, is people just have this. Oh, 9 choose 4 is 9 factorial over 4 factorial. That's not what it is. It's close, But you also have to take the difference. 9 minus 4 is 5, and that also goes in the denominator. So if I were to expand this out, I get what? I get 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. I don't want to multiply that out. I'm not going to have to multiply that out. Why? Here, I'll show you in a second. 4 factorial is what? 4 times 3 times 2 times 1. 5 factorial is what? Well, it's 5 times 4 times 3 times 2 times 1. So what happened here at the end? I have the same numbers over the top of each other, right? 4, 3, 2, 1. So they all cancel out. So really, all that I'm left with is 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. I can still make this simple. So you don't get to use a calculator on your exams, in class or final. So if you had to figure this out, you don't want to multiply 9 times 8 times 7 times 6 and then divide it by that. So let's simplify. Well, 4 cancels with 8 gives me 2. 2 cancels with 2 gives me 1. 3 cancels with 9 gives me 3. So I'm really left with what? 3 times 1 times 7 times 6, and everything in the denominator is now 1. So when I do 3 times 7 times 6, that's a little easier for me to multiply out, and that gives me 126. So a lot easier. Let me write here. I don't know if it showed up on the edge of the camera. So equals 126. So how about another example? What if I have 100, choose 3? Well, in this one, it's what? It's 100 factorial over 3 factorial times 100 minus 3 is 97 factorial. So just like with this last example, this is really what? 100 times 99 times 98 times 97, 96, 95, which is what? 97 factorial. So 97 all the way down to 1. 3 factorial is 321 over 97 factorial. So the 97 factorials cancel each other out. Now you're left with 100 times 99 times 98 over 3 times 2 times 1, which is 6, which gives you not a very nice number, 161,700. But it beats the heck out of multiplying 100 numbers together. So use that to your advantage to simplify the math a little bit. Lastly, what if I have 100 choose 97? Well, this is what? This is 100 factorial divided by 97 factorial. 100 minus 97 is what? 3 factorial. Well, what do I have? The exact same thing as I had in example 2. It's just first I have 97 and then I have 3, but multiplication is commutative, so the order doesn't matter, right? So 100 choose 3 is the same as 100 choose 97, which is 161,700. So, why did we do all that? How does this impact anything? Well, let's go back to Pascal's triangle. Pascal's triangle. See, I keep saying Pascal, sorry. So, if we had a plus b to the 4th power, if I do my binomial coefficient, I have 4, I'm going to start at 0. 4, 1, 4, 2, 4, 3, 4, 4. 4 choose 0. Anything choose 0 is always just going to be whatever that number is. Anything choose 0 is always going to be 1. And why is that? Because I have 4 factorial over 0 factorial, 4 factorial. These cancel out. We know that 0 factorial is 1. So anything choose 0 is always 1. And similarly, n choose n is also 1. Because remember, just as I have 100 choose 3 is the same as 100 choose 97, the same happens here. 4 choose 0 is the same as 4 choose 4, which is 1. How about 4 choose 1? Well, in that case, we have what? 4 factorial over 1 factorial over 3 factorial. So that means this guy is 4 times 3 times 2 times 1. So the 4 times 3 factorial, 1 factorial, 3 factorial, they cancel out, gives us 4. So 4 choose 1 is the same as 4 choose 3, which is 4. And then lastly, 4 choose 2, if you do the math, ends up giving you 6. And what do we have here? 1, 4, 6, 4, 1, which is the same as when we did Pascal's triangle for to the 4th power. So all we need to do is do this power is our value for n, and then all the different coefficient terms, 0 through 4. And this will give us the coefficients that we would have for Pascal's triangle if we were in the 4th row. So that's that. Introduction to the coefficient, binomial coefficient. That wraps up video 2. Come on back and we'll look how we put it all together now and actually are able to use the binomial theorem that if we're given a binomial term raised to a power, how can that help us out and make our life a lot easier.